All right, guys, so here are the big ideas for part 1. Again, this is about the basics of hypothesis tests, so just the ideas behind them. I also want to note that hypothesis tests can also be called tests of significance or significance tests. Okay, and you'll see why in just a minute. So the first learning target for today is about the hypotheses. So we have these technical names for them called the null hypothesis and the alternative hypothesis, okay? So the null is always the one where we use the equal sign, and we call that H naught. It looks like H sub 0, but the way we read that is H naught. Okay, so then we put whatever our parameter is. Sometimes we're talking about mean, sometimes we're talking about proportion. So I'm just emphasizing that this is the parameter that we put here, right? I won't have both of these here at the same time. I'll choose one. We put the parameter is equal to some null value. Now we call it the null value because it's kind of like our baseline. In the previous problem, our null value was 0.8, right? That 80% is the assumption that we're making, that I am an 80% shooter. P equals 0.8. Okay, I'm going to keep that null value for the alternative hypothesis, but I'm going to change it from an inequality to something that is not an equality, either not equal to, right? That could be it is less or it is more, or I'll specify I think it's less or I think it's more. So that's again the alternative hypothesis. Now, I think it's much more common to see H sub A being for alternative, and the way I remember that is ho-ha, null comes before alternative, right? But your book uses H sub 1 instead of HA. So H1 is what we'll call all alternative. Again, I'll use H1 as we go through in the notes, but if you ever see HA out there, it means the same thing. Okay, so again, the alternative hypothesis is where we put in our parameter, mu or p, whichever it is that we're dealing with, and then we'll say that is not equal to, it's less than, or it's more. So looking back at our assumptions that we talked about in part 1, these are actually our hypotheses, right? So I'm going to fill this in. This would be the null hypothesis. And since I was talking about a proportion, I would say if I think Mrs. Bakula is an 80% shooter, that is that P is equal to 0.8. Okay, so then my alternative hypothesis is this second part. I'm going to say H1 again. Mrs. Bakula is not actually an 80% free throw shooter. Okay, so in that case, now, did we think that she was better than an 80% free throw shooter? No, right? We're thinking that this is less than an 80% free throw shooter. So I would say that P is less than 0.8. And that is what we ended up calculating over here, right? The probability of it being less than that sample result that we got. So again, the null value stays the same, right? The first one is equal, and then the second one is not equal in some way. So those are the hypotheses. Okay, so the learning target number 2 is about p-values, and this is the probability of getting the sample result or more extreme, right, or something more extreme purely by chance if the null is true. So there are 2 things that are important there. Or more extreme. You're always going to be calculating an inequality, right? We did less than 0.64, which was the sample results. Purely by chance, if the null is true. This is the assumption we'll always be making. We'll assume the null is true, and then we'll see if we have evidence against that. Okay, so I did want to point out on this previous page here, let's see, where our p-value cropped up. This percentage right here, the dots that represent a percentage of 64% or less, that gave us our p-value. And so when we were interpreting that percentage, we were interpreting the p-value in context. And so you'll see interpretations like this a lot as we move through the notes, interpreting the p-value. Okay, so then learning target number 3 is about the conclusions that we can draw from significance tests. So we'll say we either do or we do not have evidence against the null, right? Sometimes instead of just saying against the null, so instead of saying she's not an 80% free throw shooter, we'll say we have evidence for the alternative, so that she is less than an 80% free throw shooter. Okay, you'll also see this technical language of reject or fail to reject the null. So let's think about this. If we do have evidence, I'm actually going to change color to try to point this out. If we do have evidence, convincing evidence against the null, we can reject the null, right? If we have convincing evidence the null is not true, then we're going to reject that idea. And then here I'm going to start with some double negatives here. If we do not have evidence against the null, right? If we do not have convincing evidence, then we cannot reject the null. So we will fail to reject it. And that fail to reject double negative, it can be kind of confusing. But it's basically saying we don't have enough evidence to say that the first assumption is not true. We cannot reject it. We're failing to do so. Okay, so those are our two conclusions, and I'll point out where we talk about this reject and fail to reject, again, more in the notes later. The other thing that we haven't really talked about yet is this alpha, right? We've seen this in our note or our book at some points. This is the first time I think I'm mentioning it in the notes. This is called the significance level, and it does have a connection to the confidence level, right? A significance level of alpha, let's say equal to 0.05, like we used up here, right? This was actually our significance level, would correspond to like a 95% confidence level in a confidence interval. Okay, so this is our significance level, and basically what we're saying is that if the p-value is less than that value that you choose for alpha, then the results are significant. You have convincing evidence, right? Significant and convincing evidence go together. So I know I'm going to get lots of questions about how do you choose alpha? And there is some discussion of that in your textbook, but it gets a little bit more complicated than I think we need for this class. So I'm going to tell you that it's usually a value between 0.1, so like 10%, and 0.01, so like 1%, with 0.05 or 5% being the most common value. We're going to talk about the consequences of tests on the next page, and then we'll talk about why you might choose a lower or a higher alpha level. But we'll see 0.05 a lot. Okay, so let's do the check your understanding. Make sure we're kind of clear on those hypothesis, the p-value, and the or how to interpret the p-value, and then the conclusions. So this problem says calcium is a vital nutrient for healthy bones and teeth. The National Institutes of Health recommends a calcium intake of 1,300 milligrams per day for teenagers. The NIH is concerned that teenagers are not getting enough calcium on average. So is this true? That's the question that we are trying to answer, the claim we're trying to test, that teenagers are not getting enough calcium. Okay, so the null hypothesis is usually kind of like the boring one, that nothing has changed. It's null, no change. So the first part says state appropriate hypotheses for performing a significance test, and be sure to define the parameter of interest. We will always have to actually define what our parameter is. Okay, so the boring thing would be that teenagers are getting enough, right? They're concerned that they're not getting enough, but the boring thing would be that they are. So if they're getting enough, they are getting a calcium intake of 1,300 milligrams per day. So let's start with our null, H naught. Okay, what is the parameter? Let's see. Concerned they're not getting calcium on average. That tells us that we're dealing with a mean, so I'm going to use mu. Okay, so their average, let's actually think about what that parameter would be even before we move into our significance test. Mu would be a true mean for what? A true mean, let's look back up here. It's per day, so I'm going to say daily calcium intake. And it's not for everyone, right? They specify the population for teenagers. Okay, so if nothing has changed, then mu is actually equal to that recommendation of 1,300 milligrams. Okay, so the alternative then, see, I'm so used to writing ho and ha. I have to get used to writing the one there, H1. Now we need to decide, do we want it to just be not equal to, that they are not getting 1,300, or do we want it to be less than, they're getting less than 1,300, or do we want it to be more than, they're getting more than 1,300? Well, let's look back up at the problem. It says the NIH is concerned that they're not getting enough. So that's what tells me that it's going to be less than, right? They are interested in providing convincing evidence that mu is less than 1,300. Okay, so there are my hypotheses and my parameter of interest is stated. So then it says researchers decided to perform a test using the hypothesis that we just came up with. They ask a random sample of 20 teens, that's probably important later, to record their food and drink consumption for one day. The researchers then compute the calcium intake for each student. And data analysis reveals that the sample mean is 1,198 milligrams, and the standard deviation is 411 milligrams. So researchers performed a significance test and obtained a p-value of 0.1404. Okay, that was a lot of information. Basically, all of this, right, that first part, that would be relevant if we were actually going to perform the significance test on our own, but we're not, right? They did it for us, right? It says it right there. Researchers performed a significance test. They did it for us. What's important now is this p-value that they came up with, okay? So it says explain what it would mean for the null hypothesis to be true in this setting, right? What does mu equal 1300 actually mean? So if the null, H naught, of mu equal to 1300 is true, it means that teenagers, let's see, I'm talking about teenagers, right? If mu is equal to 1300, it's not saying that teenagers, every single one of them gets 1300 milligrams per day, but the teenagers have a mean or an average daily intake, or I should say daily calcium intake specifically. Daily calcium intake of 1300 milligrams. Okay, so that's what it would mean if the null hypothesis is true, so then we can interpret the p-value using that. So assuming that null is true, assuming teens mean daily calcium intake really is 1300 milligrams, then the p-value is going to be the probability of getting the sample results we found. So look back up to the problem. It says they got a sample mean of 1,198. So of getting a sample, and instead of saying sample results, I'm going to say sample mean, because that's what it was, of 1,198 milligrams. And then it has to be or more extreme. So in this case, 1,198 is less than 1,300, so more extreme would be less or less, purely by chance. Okay, that p-value represents the probability of getting a sample mean of 1,198 milligrams or less purely by chance, and that probability is for us the p-value 0.1404, which would be about 14%. Right, so 14% isn't a high number, but it's also not such a low number that we think that this didn't happen by chance. And we figure that out by comparing it to our significance level. And it does say specifically what conclusion would you make at the alpha equal to 0.05 level. So they're telling us to use that significant level of 0.05. So we'll say because the p-value equal to 0.1404 is greater than alpha equal to 0.05, right? This is different from the last conclusion we made. This time, our p-value is greater than alpha. That's not convincing, right? We are going to fail to reject H naught, right? This is not significant. The results are not unlikely enough to be significant. We fail to reject. We do not have convincing evidence against the null hypothesis. Now, as we move forward in constructing our hypothesis test, we will never leave it as the null hypothesis. We will actually put that in context. But for the purposes of this check your understanding, I think we can leave it at that. Okay, we'll do part 2 in the next video.